Hello, KubeCon. 2.5 years ago, our industry changed fundamentally. ChatGPT brought AI into every organization. Next generation models ingested more and more and more and more of humanity's knowledge and got bigger and bigger. And the way we interacted with these models got bigger as well. We moved from just chat to multimodal AI. We also got bigger in how we interacted with them. Instead of just having small snippets of text, we had enormous volumes of context state. But state has weight. All of this data in one big monolith wasn't sustainable, and it wasn't scalable. So we had to break up the monolith again. We need to move to smaller models. Smaller models means orchestration. And we also want agents that are interacting with the various parts of the system, which is distributed computing. So if you squint, this should look really quite familiar. This should look a lot like the same kinds of patterns that we've already solved with Kubernetes, which is awesome. But there's always a but. These systems have an awful lot of state. The model, the paradigm that we've been working with for cloud native is that stateless is good. AI is the opposite. AI is all about state. So the question is, how do we evolve? How do we shift that paradigm to make Kubernetes AI native?
So let's not forget that Kubernetes already provides very strong primitives for us to manage state. We have persistent volumes, which provides durable storage. We've got stateful sets that provides us with a stable identity and access to storage for pods. And we also have daemon set that provide us with a consistent way of deploying pod across node. And to some extent, that allows us to have kind of node-level state management. We can also tap on the growing and thriving ecosystem for data on Kubernetes. I would mention projects such as Vitess, which provides cloud-native distributed MySQL at scale. Or projects like Rook, which provide us for an orchestration for storage systems such as Ceph. We also have been seeing a growing interest in event-driven architecture, and projects such as Keynote or Streamz, which enable Kafka on Kubernetes, have helped us to build dynamically linked applications and microservices. But AI workloads operate at a totally different scale. If you look at state management, AI agents just don't store state. They share, they modify, and they react to data in a very dynamic and high volume and high throughput manner. So the current construct that we have, they need to evolve, and they need to evolve because we are already dealing with huge issues at large scale. We deal with issues such as data locality, synchronization, and performance bottlenecks. So going forward, we need to start looking at how to make scheduling AI native in Kubernetes and how to handle state management better. AI workloads are very intensive in terms of memory and compute consumption. So we can leverage NUMA-aware AI scheduling to deal with the memory aspects. We can also use GPU and topology-aware AI scheduling to make sure that we use our compute and our access to accelerators better. We also have LLM Gateway that will provide us with an efficient way to route inference requests to those very high-consuming large language models that we are all trying to use. But the biggest challenge we have is we need a fully new model for fault-tolerant management. Why is that? AI agents don't fail in a traditional way. They may fail by producing a wrong output, and we need to be able to recover from this type of issue in a distributed system. So going forward, we are going to have to deal with a better way to manage state at scale for those highly distributed systems. Thankfully, CNCF projects already provide us with a strong foundation to do this. Q is an extremely interesting workload management capability on Kubernetes. We have Envoy AI Gateway, Kserve and VLM that provide us with a scalable inference management for Gen AI model. And we've got deeper and deeper agents that help us build highly distributed, intelligent architecture and systems. Finally, OpenTelemetry is a very, very big dependency for us when we are starting to look at how to correlate observability across dynamic AI agents.
And you can read about the progress that the CNCF AI working group has made. There's a really good white paper showing that there's lots of progress already because we've got such a strong foundation. We've got such an amazing ecosystem and community. We can lead this shift towards decentralized AI because AI is going to change cloud native and it's going to move to intelligent state aware, but we can build this together. So if you'd like to hear more, Vincent has a talk tomorrow about AI on Kube. We've also got a live Red Hat demo this afternoon at 3:30 in the demo theater. And then, of course, do come see us at the Red Hat booth. Thank you very much.
Yeah.
Thank you so much.